plus dot, dot, dot. There's more things going on. Okay? This can look a lot of different ways. Okay? But I know something. Because my first coefficient is positive and my biggest exponent is even, I know at the ends it's going to be a touchdown.
Is that right?
So it's good. So could this? Now sometimes these polynomials get these weird waves in the middle. We'll get in more detail on those later in the week. But for now, could this polynomial come from an equation that looks like that?
Yes.
Yes, because a is greater than 0 and n is even, and I have indicated that it keeps on going up forever at the ends. That's the end behavior.
What if n were odd?
Let us do that.
That would go down, right?
Perfect segue.
Nope.
Is that a note of my question or Brian?
It's a note of Brian's question. Sorry. Okay. If a is positive and n is odd, the end behavior is what I call ballerina. Okay? And the simplest example of this, Jordan, stay with us, is y equals 1x cubed. If I graph y equals 1x cubed, it looks something like that.
If A is bigger than 0?
Yeah, a is bigger than 0, positive. It looks something like this. It always goes down on your left side and up on your right side. Okay? And we call this a ballerina because I'm standing kind of like a ballerina.
Does that have to do anything with the sign?
Not yet. No, but it looks kind of like one, but we're getting there. We're not going to tie that in until later.
Okay.
Good thought, though.
Because I was taking an A60 prep test at home with my dad.
Okay. We don't have much time. If y equals something like 5x cubed plus dot, 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 and there's a bunch of other terms here, this could wind up looking something like that. Actually, no, it couldn't. Make that 5x to the 5th. Okay? This graph could come from here because it has a positive number at the front and an odd exponent at the very ends. Ignore all the curves in the middle. At the very ends, does this follow a ballerina pattern?
Sure. Yeah.
Yes. Down to this side, up to this side.
If it's a negative number, are both sides pointing down?
Okay. I'll have to write these very quickly, unfortunately, these last two. Follow me, Eliza?
Oh.
Okay. If a is negative and n is even, for a really simple example, y equals negative x squared, you get this. Okay? Last year, the term we decided for this was marionette.
As in a puppet?
Yeah, because it's hanging like a puppet like this. The arms are hanging down here. I wanted to say puppet, but it turns out a puppet with strings is a marionette. So they didn't like puppet terms. Because puppets always look like this, when someone's hands in them. So marionette was more the term.
It'd be really uncomfortable.
To have your puppet do this.
Yeah.
And if a is less than 0 and n is odd.
Wait, is it on both sides or just?
Yeah, it's on both sides. It's going to be going down on both sides. Another example of the marionette, they can look like this. They can have little waves in the middle. We'll get to. Okay? Now, last one, if a is 0 and n is odd, then you've got...
Is less than 0?
Yes.
Okay.
A is less than 0. You have a reverse ballerina. So if you just have y equals negative x cubed, then your ballerina has the other arm up and the other arm down.
I can see.
In other words, it starts up here positive to your left and comes down and goes negative to your right. I apologize I had to rush those last two. The homework tonight will involve things like matching and just generally describing this behavior. You're not going to have to do any specifics or plug in any numbers, okay? We'll get into that soon. But remember, basically, every polynomial has end behavior, even if it has lumps in the middle, that is either a touchdown, a marionette, a ballerina, or a reverse ballerina. That's at the very end. More details tomorrow. The homework is...
It's online.
Yes, but it's page 333.
Hold up.
Page 333, just in case you have a power outage from a falling tree limb or something.
Call someone.
1526 all.
Is that it?
Nope, and that's just identifying what is and isn't a polynomial. And 49 to 64 all.